Welcome back. In this video, we're going to continue looking at chemical reactions, and we're going to focus on determining and using limiting reactants, also referred to as limiting reagents. In a previous video, we did this calculation where we took 1 gallon of gasoline, we combusted it with oxygen, and we evaluated how much carbon dioxide would be produced. We made some assumptions about the density and identity of the gasoline. However, we also assumed that there was an unlimited amount of oxygen. Now we're going to examine what would have happened if this were not the case. Or in other words, is it possible that we could have produced less carbon dioxide depending on the amount of oxygen that was present? The short answer is yes. So the amount of products that can be formed depends upon how much of each reactant or reagent you have. And specifically, it's going to depend on the amount of the limiting reactant. For a given chemical reaction, the limiting reactant is the one that's used up first. Hence, it limits our productivity. And we can identify the limiting reactant in one of two different ways. One way is to compare how much of one reactant is needed to react fully with the other, or we could compare how much of each reactant produces a given product. Either of those methods, comparing amount of reactants needed or amount of product produced, will allow us to determine which one is our limiting reactant. In the case of comparing the amount of reactants, let's say that you have reactant A and reactant B. If you have 10 molecules of A and 10 molecules of B, and it's determined that you need 8 molecules of B in order to completely use up all of your molecules of A, then you know that you'll have leftover molecules of B and A will run out first. However, if we have a reaction that combines A and B and produces some molecule C, if you do the calculation and we see that with A we could produce 5 molecules of C and with B we could produce 4 molecules of C, we see that B is our limiting reactant and it runs out first because it would have produced less of molecule C. So let's do a practice problem here. Pause the video, read over the question, and try and determine how many ice cream sandwiches we can make using cookies and scoops of ice cream. Welcome back. What did you determine? Hopefully, you came to the conclusion that you can't answer this question. It's a trick. Now, how so? Well, take a look at the information you have in terms of the amount of cookies and ice cream versus what you actually need to make the ice cream sandwiches. You're given a mass of cookies and of ice cream. However, you're not told how many grams of cookies you need or how many ounces of ice cream you need. You're told the number of cookies and the number of scoops of ice cream. So what we need to know is what is the ratio of grams of cookies to the number of cookies, and what is the ratio of ounces of ice creams to scoops. So let's just say that 1 cookie weighs 15 grams and 1 scoop is equal to 30 ounces. At that point, you now should have enough information to solve. Now, pause the video again and try and determine how many ice cream sandwiches we could make. Welcome back. So, we need to first find out how many cookies we have and how many scoops of ice cream. And that's because our balanced chemical equation is given in terms of the number of cookies and the number of scoops of ice cream. So if we have 120 grams of cookies and each cookie weighs 15 grams, we see that we have 8 cookies. If we used all 8 cookies and it took 2 cookies to make 1 sandwich, we could make 4 sandwiches. Now, looking at the ice cream, if we have 90 ounces of ice cream and each scoop is 30 ounces, then we would end up with 3 scoops of ice cream. If we used all of our scoops of ice cream, it takes 1 scoop per sandwich, we would make 3 sandwiches. So which is it? Do we make 4? Do we make 3? Well, hopefully you should see that it's impossible to make 4 sandwiches when we only have enough ice cream for 3. So ice cream is our limiting reagent. Notice that when we did these calculations, that we evaluated 2 different types of information. We evaluated the information that we had, the amounts of substances, 120 grams of cookies, 90 ounces of ice cream. We also evaluated the balanced chemical equation, the ratio of the amount of each substance that we needed. We need to consider both the amounts of the materials that were given and the balanced chemical equation. Very frequently, students make mistakes and they just take a look at the balanced chemical equation and say, well, clearly, if I need 2 cookies and 1 scoop of ice cream, then I have 2 cookies and 1 scoop of ice cream, without actually accounting for the materials that they have. What if you have no ice cream at all in your freezer? You can't make an ice cream sandwich. All right, here's a real chemical problem for you to practice on. Pause the video and try and determine this one on your own, and then come back and I'll walk you through a solution. Welcome back. In this question, we are given that we have 36.6 grams of C2H5OH, which is ethanol. It reacts with a certain amount of oxygen, and we want to know how many grams of carbon dioxide would be produced. You should be able to recognize this as a combustion type reaction. And because we're given the masses of each substance, it's not clear which one we'll run out of first. So what we need to do is find out how many moles of each substance we would have, and either compute how much of the carbon dioxide we would produce, or how much of each reactant would be used up. Let's start by use the table method here to try and solve this problem. So we are given information about the masses. We've got 36.6 grams of the ethanol, 63.8 grams of oxygen. And we start with no amount of carbon dioxide or water. What's the relationship between mass and molar mass, or excuse me, mass and moles? The answer is the molar mass. And the molar mass of ethanol is 46.1 grams per mole, and oxygen is 32 grams per mole. To find the moles, that's determined by taking the mass and dividing by the molar mass. When we do that, we get our initial moles is 0.794 moles of ethanol and 1.99 moles of oxygen. So now the question is, how much carbon dioxide will be produced? From this, it seems fairly clear, at least initially, that we're going to run out of ethanol, and so it will be our limiting reactant. However, you need to be careful and not just assume that whatever you have the least of is going to run out first. So let's identify the limiting reactant. Since we have 2 choices, we can either find out how much oxygen would be needed based on the amount of ethanol we have, or how much ethanol would be needed based on the amount of oxygen we have. And so that would be finding the amounts of reactants needed. Or we can look at the amount of product that would be made from using the total amount of either of our reactants. Let's make that calculation. The reason that I'm choosing to determine how much product we would make is because in the end, we want to know how much product is made. So this will allow us to continue making steps in that direction. So how much CO2 would be made if we used up all of our ethanol? To make that calculation, we take the amount of ethanol that we have and we multiply by the ratio. 1 mole of the ethanol produces 2 moles of carbon dioxide. That would be 1.59 moles of carbon dioxide produced. If we want to know based on the oxygen, carbon dioxide from oxygen, that's going to be 1.99 moles of oxygen times that ratio, which is 3 moles of oxygen for every 2 moles of carbon dioxide. That would produce 1.33 moles of carbon dioxide. So it's a good thing we didn't just assume that the ethanol was going to run out first. Using ethanol, we would be able to produce more carbon dioxide. Therefore, oxygen is going to be our limiting reactant. It produces the least amount. So then when we look at our change of moles, we're going to run out of oxygen and there's none of it left over. We don't really care how much of the ethanol is left over in this problem, so let's not even compute it. We know that the amount of carbon dioxide is 1.33 moles produced. And so our final amounts are 1.33 moles of carbon dioxide. If we want to know how many grams, that's going to be found, again, using this relationship, mass equals moles times molar mass, which is 1.33 moles of carbon dioxide times 44 grams per mole. And that's going to be equal to 58.6 grams of carbon dioxide. Okay, that's it for this video. Thanks for watching. Have a great day.